Hello students, welcome to online lecture series of Additive Mathematics. Now today we'll see mathematical induction. So what are the different steps in mathematical inductions? So you have to remember 3 steps for this mathematical induction for the exam point of view. So first step is a basis of induction. Second step, induction hypothesis, and third step, induction state. In some books mention only 2 steps, that is basis of induction and induction step. Now here we are solving the example using 3 steps: basis of induction, induction hypothesis, and induction step. So this is the example. So prove by induction. That is 1 plus 2 plus 3 plus n up to n into n plus 1 divided by 2 for all natural number values of n. So what are these 3 steps? Before start with the example, so we understand what are these 3 steps. That is basis of induction, induction hypothesis, and induction step. So basis of induction. So here we have to assume that, just here, not assume that, here we have to prove that n is equal to 1 is true for the given statement. So here suppose we have to assume that is S of n. S of n is a statement, and here we have to assume that this S of n is true for this n is equal to n. Means that it is a unity that S of 1 is true. So for that we have to prove LHS equal to RHS. In second step, induction hypothesis. So induction hypothesis. Hypothesis means what? Here we make we made some assumptions. That is, we assume that this S of n is true for n is equal to k. Right? This S of n, this statement is true for this n is equal to k. That is, we assume that S of k is true. We assume that S of k is true for n is equal to k. In third step, induction step. So here we have to prove that S of n is true for n, that is n is equal to k plus 1. Means here we also have to prove S of k plus 1 is also true. S of k plus 1 is also true for n is equal to k plus 1. So here you have to prove n is equal to 1, right? By putting n is equal to 1, you have to prove S of n is true for n is equal to 1. Then we have to assume that S of n is true for n is equal to k. And in third step, again we have to prove that S of n is true for n is equal to k plus 1. That is, we have to prove S of k plus 1 is true. So we'll see an example. Prove by mathematical induction, right? 1 plus 2 plus 3 up to n is equal to n into n plus 1 divided by 2 for all natural number values of n. So here, what is your statement? So here, first write down S of n is 1 plus 2 plus 3 up to n is equal to n into n plus 1 divided by 2. So this is your statement. So first step, step 1, basis of induction. So for basis of induction, put n is equal to 1 in your equation number 1. So this is your equation number 1. That is what is your statement? So this is your equation number 1. So put n is equal to 1 in that equation 1. So here, after putting equation putting n is equal to 1 in equation 1, so LHS equal to 1, RHS equal to 1 into 1 plus 1 divided by 2. So that is 1. So LHS equal to RHS. Therefore, n is true for 1. So S of 1 or S of n is true for n equal to 1. Second step, induction hypothesis. So what is this induction hypothesis? So we know the induction hypothesis. We assume that S of n is true for n is equal to k. So here put n is equal to k in your equation number 1. So 1 plus 2 plus up to, that is k. So it's n is equal to k. So here is k equal to k in bracket k plus 1 divided by 2. So this is equation number 2. So we assume that this equation is true. Next, third step is induction step. Here we have to prove that this S of k plus 1 is true. So here put n is equal to k plus 1. So here 1 plus 2 plus 3 plus 2. Instead of n, put n is equal to k plus 1 equal to. Here is n, so k plus 1, n plus 1. So there is in bracket k plus 1 divided by 2. So k plus 1 into k plus 2 divided by 2. So here 1 plus 2 plus 3 up to k plus 1. So what is the previous value of this k plus 1? Previous value for this k plus 1 is k. Is k. Next is k plus 1. Right? So previous value for this k plus 1. So 1 plus 2 plus 3 up to k. Right? And next k plus 1. So by induction hypothesis, right? By induction hypothesis, this term is 1 plus 2 plus 3 plus up to k is equal to, right? See, in induction hypothesis, this is induction hypothesis. So 1 plus 2 plus up to k is equal to k into k plus 1 divided by 2. So we already assume that this statement is true. So just put this statement, right? Put this value here. That is by induction hypothesis. So k upon k plus 1 divided by 2 plus k plus 1 plus k plus 1. So it's k plus 1 into k plus 2 as it is. That is RHS value is as it is. So LHS again k into k plus 1 plus 2 k plus 1 divided by 2. By solving this term, right, we will get k plus 1 into k plus 1 k plus 2 divided by 2. That is equal to k plus 1 k plus 2 divided by 2. So that is LHS equal to RHS. Means here n is true for n is equal to k plus 1. Therefore, we can say that n is true for all the values of n, where n is all the natural numbers. All natural numbers. So stop here. In next session, we'll see another example related with this mathematical induction.